This is Module 3, Problem 6. We're starting to enter the calculations for our hypothesis testing. And the first test we're going to do is a very simple test, the single sample hypothesis test. We're going to compare our sample of the weights of our participants in the UMMA, the Ultimate Mixed Martial Arts team at William & Mary, versus other universities where we have a weight for the typical university, average weight for the typical university to be 163.8. We look at our members of our team and we calculate a value, and it'll be below that. It'll be 153, I believe. So we're going to see if we believe from a hypothesis testing point of view that William & Mary is different from the typical college team weight. So how do we do that? Well, first we're going to need to look at the data. We look at our data, and we're going to concentrate on the data we see here on the right. The data is all the same here, except I've sorted it over here, all men and all women. We'll use that information later in another problem. But for the interim, we find that our 45 competitors, men and women at different weights, the average weight is 153.6 pounds with a standard deviation 24.2. So that's the information that we have from our sample. Our problem then is to set up, first of all, a hypothesis test, and then second, test a hypothesis, the null hypothesis, versus an alternative. So here is our hypothesis test. The mean of the intramural mixed martial arts team at William & Mary is equal to, the standard for all schools is equal to that of William & Mary. Our alternative, H sub A or H sub 1, whichever you prefer, is that either William & Mary is less than, because we find evidence of that in our sample, than the mean of all of the UMAC teams in the country, or we can simply say it's just different. This is a one-tailed test because we have directionality here. This is a two-tailed test because we don't have directionality. We just say it's simply different. So here's our data. We've got two approaches here that we can use. First of all, we can use the approach we use with Excel. Excel does not have a standard one sample test in its data analysis package. So you have to do these calculations yourself. And what I've done here is I've done these calculations for us using the PowerPoint information that we had before. I calculate a t-statistic. Remember, the t-statistic is the difference between our value that we get and the proposed value that we are looking at as the standard, D36 minus D35, 36 versus 35, 36, 35, calculate the difference, and then we divide that difference by D55, which is the standard deviation divided by the square root of n. This is our standard error in the problem. So we calculate a t-stat here, and the t-stat is the difference between the two. It could be positive or negative. We're just trying to see if the t-stat that we calculate is different from the critical values. We're going to use the negative y because we know that we were lighter than the other teams. So our second calculation is a calculation for the one-tail critical value. We use the TINV function, and then the values here are the probability of 0.05, which is our alpha, and our sample size, 45 minus 1, because these are degrees of freedom. Here, degrees of freedom, or the sample size minus 1 because we've lost 1 degree of freedom through estimation. So here's our value. We ask the question, is this value more extreme than this value? Well, yes, it is. If you look at the drawing that I have over here, here are the two values of negative 1.68, positive 1.68, and negative 0.282 is more negative than this value. So we reject the null hypothesis because it is more extreme than the value here. Let's look at a two-tailed test. In a two-tailed test, we calculate a different critical value, and in this particular case, we use the t inverse dot 2t, two tails, and we put in our parameters alpha and our sample size, and we get a value of negative 2.01, and in fact, in this particular case, our value of 2.82 is in fact more negative than this value. So again, both in the two-tail and the one-tail test, I reject the null hypothesis. That was a lot of calculation. We could have done it simply by using our Minitab. We go to Minitab in the stats area. We find our one sample test. We give it information, and we calculate these t-values. We notice that the t-score here is the same as we had before. But here we simply look at the p-values and say, let's compare our alpha to this p-value. If this p-value is smaller than alpha, and clearly it's smaller here in the two-tail test, and this is a two-tail test. Why? Well, because this is an inequality here, and it is also smaller here in the one-tail test, so it is more negative, or excuse me, smaller than our alpha, and we can reject on the basis of that. So that's the end of our test of hypothesis problem 6 in module 3.